Alright, my name is Caden Dodson, and this is my midterm project for Mechatronics 470. Is a robotic arm that is controlled with a Raspberry Pi that can interface with it via an Arduino, which you see right here in the picture. It has a CNC shield on it, and the Arduino takes the commands from the Raspberry Pi and sends controls to each of the servo motors, one for that sprocket, one for the elbow right here, one just under here that controls the lower joint. They're both on worm drives. And one smaller servo up here that controls the grip. You can also see up top here there's an ultrasonic sensor that can read distance to the object being grabbed. Plus a little camera so you can see what you're doing with it when you're either away from the arm or at a funny angle. So, without further ado, you can see all the wires from the CNC shield to go to each of those motors around there. They're kind of nicely connected together. The others are bundled and run up through here to one supplies power to this driver that drives the smaller stepper motor, and then another runs power and communication to the ultrasonic sensor, and the final one actually takes commands and runs them into the driver that drives the smaller stepper motor. So, without further ado, and one last thing to mention, this breadboard down here, really its only function is to create a voltage divider so the Raspberry Pi can communicate with the ultrasonic sensor without frying itself or the sensor. So, other than that, really all this is just necessary communication stuff. This last wire you see here is just power for the motors. It runs up to this box on the left, which I'm going to plug in just a second here. And that cord obviously just powers the Raspberry Pi. The CNC shield is able to take that extra power source and use it as extra juice for the motors. So, here we go. If we run the terminal, start the code that I've created, we now connect a Wii remote, which we'll use to control the robotic arm. Rumbles when it's ready to go. Then we wait just a second, and we have a GUI. Okay, so the GUI shows whether the target's in range to grab, the distance to the object, which we haven't measured anything yet, so we'll get to that later. And I have a little counter equipped on here, so you can, by pressing a button on the Wii remote, you can count how many objects you've moved. So, I'll let you observe. Oh, and I have a little phone up here that's displaying the live feed for the camera. The camera doesn't actually go through the Pi, it's just a standalone Wi-Fi camera. So, if I hit play here, alright, we are now seeing video footage of what the camera's looking at. So, now, using the Wii remote, we can turn the claw somewhat. We can tip the whole thing, control just the elbow, and move around things like the block. You can see that the camera here is matching its movements. Sorry, sometimes the and then there's the counting function. I can say moved an object and up the counter there, so I have to be quick with the button. But other than that, that's about the gist of it. Oh, and as far as range finding goes, so see if I can back up to where you can see both the GUI and the robot. So cool thing is this is actually able to measure the distance to the ceiling. So if I back it up a hair, just for time's sake, hit plus, measure the distance. Although, seems like, I don't know what I did, the midterm prototype shows that the ultrasonic sensor is working fine, but it's not finishing its code for some reason now, so I'm not 100% sure why that's going on. But that's my project. Thanks for watching.